Well, we're about to find out. So, finding missing angles. If you have two sides of your triangle, not just one, but two, you can solve for either of the acute angles. Acute being less than 90 degrees, because if we know one angle's 90, the other two have to add up to 90. So they both have to be less than 90. That's just little common sense and logic here. So as we started to do yesterday, what we're going to give a shot to here is to do the first problem while we're filling in the steps so we can kind of see how this goes. Similar to yesterday with our side. We are going to label the sides of our triangle before we do anything else. So, even though the hole punch cut it off a little, there is my angle I'm working with. You're like, how do you know that? What's that thing? That is a Greek letter called theta. It's just like using x. It really doesn't matter. So we can have that there. Our hypotenuse is always across from the right angle. It's always our longest side as well. And then for our other two, since this is the angle I'm working with, this side is opposite, and the side that is directly connected to my angle is my adjacent. So we get our sides labeled. Then, depending on where the angle is, we've got to figure out which trig ratio we're going to use. So here are the two sides that I actually have. There's numbers at them. So I have opposite and I have hypotenuse. So which trig function are we going to be using? Sine. So here's how this works. The sine of theta equals 7 over 10. But let's put one more little piece in here. When you're looking for an angle, we're going to put that little -1 in here, and you're about to see why I do that. Because when I go to let my calculator help me out, and just like we did yesterday, we're going to make sure those shady characters and stats didn't mess with our calculators. We're going to hit mode up here at the top, and we're going to make sure that we are in degree before we get going. Some of those seniors can pull some pranks. You don't want to be playing that game. So we're in degree. What's that? To degree. Yep. Oh, see, sometimes they mess with this stuff. We got to make sure. So here, I can't just hit sine 7 over 10. That would think I'm looking for a side. So to get the -1, we're going to need to do second and sine. So let me move this up so we can see all the things. Second and sine, there's the little -1, which means I'm looking for an angle. And then I can just type in my fraction, 7 over 10. And typically with angles, we just go to the nearest whole. So this one would be 44 degrees. Okay? That's really the only difference that we're going to be looking at. So here, I don't even know if I'd call this an equation. Like, it's just punching in the fraction and we're done. So technically, this -1, if we want to use a little bit of math vocab and learn a little extra, what we're actually doing is using what's called the inverse trig ratio. That's not something that's going to be on a test or a quiz or anything. It's just saying, hey, if I see the little -1, the little inverse sign, I'm looking for an angle. That really is it. All right. Let's play with another one of these. So I look, label my sides up. There's my hypotenuse. There's my opposite. Here's my adjacent. We got adjacent and opposite. What trig ratio are we using? Tangent. Tangent, little -1. Oops, well, x, theta, we can use either, it's okay. Make sure you're going in the right order, though. So when you're doing tangent, we're opposite over adjacent. So we'll get that in. Trying to do the calculator without getting too much glare. We'll see how this goes. Second tangent, there's my little inverse. 8 divided by 4. You mean like x or theta or whatever? No, I don't care. So here's what I want you to do for a moment. I want you to do number 4, not 3, 4, and then we will get back together in just a moment to see if everything is going well or not. For those of you watching later, hopefully you hit pause on me and didn't just copy, and you can try it yourself, just say. So, if we get our sides labeled, get our angle found, notice we got adjacent and hypotenuse, which would give us cosine. Adjacent over hypotenuse, 5 over 12. Get that in again, second cosine to get my inverse. We've got ourselves an angle. So now you've got the capability of finding any side or any angle within your triangle. Not a bad thing. So I got one more thing to show before we try to put everything together tomorrow and finish this off. And that's over on page 13. Yeah, we're bouncing around again. Play it as we go here. Okay, back to the Pythagorean theorem for a minute, because sometimes you're only going to have enough information to find another side or something. You may not, have one side and one angle, or two sides. You may need a third. So, if you've got two sides of a right triangle, you can always use the Pythagorean theorem to find the third. However, as is noted here, C is always the hypotenuse. It's always the biggest side. The other two sides, for our purposes, are interchangeable. Okay? A and B. So, if the hypotenuse is what's missing, the longest side, we're just going to go ahead, type this in. And then reminder on to get the square root if you're looking for that. Okay, you can see it in blue here. So second and x squared will get you square root. And we are not, lucky for us, we are not going to concern ourselves with exact values here. We're just going to go to the nearest tenth and let the decimals play their way out. Now, here's the one where you get a choice, though. What if you have the hypotenuse, but you have a leg that's missing? Okay? There's two ways you can tackle this. I'll show you both. One is to just keep going the way you have. So x squared plus 5 squared equals 7 squared. But again, the hypotenuse has got to be on the equal side. So if I do that, I do my 5 squared, I do my 7 squared. But this time, they're on opposite sides. They're not on the same side of the equals like they were over here. So this time, we got a little more work to do. So let's see here. Second, x squared, 24. X is like 4.9. Okay? So if you're a person, Hardy, I want to do it the same way, the same order, the same type every time. Keep doing this. Okay? If you like a little bit of a way of condensing your work, here's your other option. If it's the leg that's missing, you can take the hypotenuse squared minus your leg squared and do it in one step. Because if I type 7 squared minus 5 squared in my calculator, 49 minus 25 immediately gets me to 24. Okay, do you have to do the minus thing if it's the leg missing? No. You can still just put it in, a squared plus b squared equals c squared. Just remember it's the hypotenuse you're trying to get in there. They both work. So, as we did before, I'm gonna go double freeze frame this time. Oh dear. So, I want you to try out numbers 1 and 2 on freeze, and we will come back very shortly to see what everybody has got. Again, for those of you watching later, you should be freezing me or putting me on pause until you have tried these. Oh, my pen died. Until you are ready and raring to go. All my pens are dying. Holy moly, can I get a pen that works? Try number 4. There we go. Bless you. Keep me on freeze frame here for a moment. So one of the two, you've got the hypotenuse. The other one, you're looking for the hypotenuse. So you're going to tackle them slightly differently on each one. Momentarily, we'll unfreeze here and then kind of see where we're at and how we're feeling with stuff. All right, so get these up. There's both. Again, on number 2, you could have done the 10 squared minus 7 squared equals x squared. That would work on that one, since we had the hypotenuse as one of our sides. But if you just kept it normal, subtracted the 49 over, you're fine still. So this is setting us up for tomorrow when we start doing applications, where you're going to have different pieces that happen to be missing. One time it may be an angle, the next time it may be a side, and we're going to have to adjust as we go. So get your background work done on this stuff before we get to that